The intent of this video is to explain how to calculate molar mass and mass percentage. I'll be working some of the your turn problems in your book in section 4.7, page 124. So what is molar mass? The molar mass is the mass of a compound, and we get those masses based off the masses on the periodic table. They have units of grams per mole. And remember that a mole is just is a chemist's amount of things. Okay, just like bakers have dozens, chemists have moles. It's just a number. It's a massive number. It's Avogadro's number amount. So essentially, the molar mass would be 1 mole. So if I had that many of those atoms of the compound, how much it would weigh in grams. Okay. So all you really have to do is have the molecular formula and then a periodic table handy. So if you were asked to find the molecular mass of ozone, which is O3, that means that there are 3 molecules of oxygen in that atom, or in that, sorry, 3 molecules of oxygen in that compound. So go to your periodic table, either the PDF that you can download, or there's one in the back of your textbook in the after the appendix, and you'll find that oxygen weighs 15.999 grams per mole. Okay. So that's just 1 atom of oxygen, but I don't have just 1, I have 3. So in order to find the molar mass of ozone, I'll need to take that number and multiply it by 3. And what do you get? So then I get my calculator here, 15.999 times 3. I get 47.997 grams per mole. So ozone O3 weighs 47.997 grams per mole. Let's work another example. What about dinitrogen monoxide? Dinitrogen monoxide, NO2. So this compound is made up of 2 different atoms. One's oxygen and the other is nitrogen. Okay. In each 1 molecule of dinitrogen monoxide, there are 2 nitrogen atoms, right, and only 1 oxygen atom. So the molar mass, sometimes also called the molecular weight, is going to be equal to 1 times the oxygen, which was 15.999 grams per mole, plus 2 times the mass of nitrogen. Again, you're going to have to go look on your periodic table. This is something that I would not expect you to know off the top of your head. I know all the rounded numbers that I use, but I don't remember all the exact numbers. So nitrogen is 14.01 grams per mole. So in order to get the total molecular weight, right, we do, I'm going to do 2 times 14.01 equals 28.02. So this value is 28.02. Plus this 15.9999, so plus 15.999, and the molecular weight of dinitrogen monoxide is 44.019 grams per mole. All right, let's work one more example. I'm going to turn down the thickness of my pen a little bit. Last example, let's look at Freon 11, which is CCl3F, CCl3F, also known as Freon 11. So what is the molecular weight or the molar mass of this compound? So notice off the bat, we have 3 different types of atoms. We have carbon, chlorine, and fluorine. We have 3 chlorines, 1 carbon, and 1 fluorine. So we're going to have to go on the periodic table and find the masses of those 3 atoms and do the proper stoichiometric amounts, and that should be it. So carbon weighs 12, I'm at the periodic table, so 1 times 12.01 plus 3 times, chlorine is 35.45 plus 1 times, and fluorine is 19.00 grams per mole. All right, so take my calculator, and I always usually just start with the bigger numbers to multiply. So I'm going to do 3 times 35.45. That gives me 106.35 grams per mole plus 19.00 plus 12.01, and which gives me a grand total of 137.36 grams per mole. And that's for Freon 11. So that's some examples of how to calculate molar mass or molecular weight of compounds. But what about mass percent? So when we refer to mass percent, we're talking about the percentage of one of the atoms in that molecule over the total mass. So we can find, for this example for Freon 11, let's move it down here a little bit. So CCl3F, our Freon 11, I'm going to keep with it, and we just calculated that that is 137.36 grams per mole. That's the molecular weight of that, right? All right, excellent. So let's calculate mass percents. So out of that total mass, what percent is carbon, what percent is chlorine, and what percent is fluorine? Okay. So when you want to find a percentage of anything, it's always going to be the amount of what you're looking for over the total amount. So the total mass is 137.36. We just calculated that. So for all of these, the total would go at the bottom, right? Because it's the smaller amount that you want out of the total amount, 0.36. And so if we're looking only at carbon, we have to go back up here and say, okay, what was the total mass of this compound that was solely due to carbon? There was only one atom of carbon, so you can do the 1 times, and then you're going to need to know what was the mass of carbon. That was 12.01. So that would simplify to 12.01 over 137.36, right? Because all you have to do is multiply 1 times 12.01, and it's 12.01. So I do 12.01, and I divide that by 137.36. And, and since it's a percentage, so I have a decimal place here, I almost forgot. When we do percentages, don't forget, after you find that value, you need to multiply that by 100 to get us to our percentage. So times 100 equals 8.7%. All right, so the percent of carbon is 8.7. And that's not technically correct with the significant figure calculations when we learn about the rules of significant figures. So I'm not worried about that right now. That's in a later video. And all the chapters after this, I'll make sure to do the math according to significant figures. But just as a side note, if you've already watched that, 8.7 is not the correct number of significant figures to have in that value. In fact, I need 4 significant figures. Anyways, let's look at percent chlorine. So percent chlorine, remember, it's going to be the fraction of chlorine. So how much chlorine out of the total, which, and then remember, the total again is 137.36. And the fraction of chlorine, how much chlorine was in here? 3 molecules, and they were 35.45 grams per mole apiece. So 3 times 35.45. So let's simplify that. 3 times 35.45, 106.35. Divide that by 137.36, divided by 137.36, multiply it by 100, and I get 77.4%. All right, so chlorine, right? Carbon only makes up about 9% of the mass of that total compound. Chlorine makes up a little around 77%. And let's do fluorine just to make sure, because all of our percentages over here should total up to 100%. That should account for everything. So fluorine, remember there's 1 atom of fluorine. So 1 times, and the molecular weight of fluorine, I have to check again. Oh, it's 19 even. Times 19 divided by 137.36. So 19 over 137.36. What do we get? 19 divided by 137.36. I get, oh, times 100%, 13.8%. So what happens when we add up 13.8 plus 77.4 plus 8.7? I get a 99.9, and that is close enough. And that a little bit of error, why it's not exactly 100, is due to the rounding, right? So we did some rounding here. If you get a number between 99.9 and 100.1, it's fine. That's the 100%. It just has to do with the rounding error. So that is how you calculate the mass percent and the molecular weight of compounds. So please work some more practice problems on that.